All right. From the last part that we talked about, we actually talked about simple questions on the decibel concept. Now we are going to be focusing on the multi-stage concept, whereby you are given maybe two stages like this, or there are three or more, depending with the question that you be given. So these are typical questions from the multiple stage concept. So what I just want you to have into consideration simple things before we talk about the questions that we are given. So we have the multiple stages in this case. What is it that we are supposed to consider whenever we are dealing with multiple stages? All right, let's take a consideration that we have got our amplifiers connected together. We have got the first one here. This is the first one connected to another one. Let's just consider there are two of them. All right. So given a consideration of these two connected together, so you're saying in a multiple amplifiers, we've got multiple of them. We can have another one connected together. All right, let's say we've got the first power. Then, like I said, this is our amplifier one. So this is our amplifier. We've got amplifier one here, and we are going to have the gain of this amplifier. So there's going to be the gain of the amplifier. Remember from our introduction of the decibel concept, I said the gain can be represented by A1A. So in this case, since it's our gain one, we can just write it as A1, gain one, A1, all right? Once this power is transmitted, we are going to have our power 2, our power 3 in this case, to the second amplifier in this case. So we are now having our second amplifier, which is our amplifier 2 in this case. So we have got our amplifier 2 with its gain. So we have got gain 2, which we can write as A2, representing the gain. So what you need to know is that if multiple amplifiers are staged like what we see here, their respective gains, which is the one that is corresponding to the overall of everything, is going to be equal to the product. So the overall gain taken from what we refer to as the product. So we have what we refer to as the product ratio method to obtain the overall gain. In this case, we want to obtain the overall gain. So we have got the first method that we can refer as the ratio method, which is the product ratio, which states that the overall gain in this case is going to be equivalent to the product, like the product method. So it will be the product of the given gains. All right, so taking this as our total gain, which is our overall gain, we can say is the product of gain 1 times gain 2. So we are going to multiply the first gain to the second gain. All right, but remembering that gain is represented by A, so we can use A1 and A2. So you're going to multiply A1 times A2 like this. So that's you have the overall gain using the product ratio or the product ratio method. We can refer it as the ratio method or the product. So if we are to consider a condition like where we are using the power, let's say we want to talk about this power that we have here. Remember what I said in our previous class about the gain, to say gain can be calculated from, if we are talking about here, the first gain, we are going to use the output power over input. So it's going to be P2 over P1. That's where we've got the first gain. So A1 is same as P2 over P1. And power, it can be calculated from whatever that you're given. Maybe you're given voltage and current, you're given current and resistance. You calculate power from the information that you're given, but I'm referring to the power as it is, it's output over input. And the second one, which is our gain 2, is going to be the same output, which is P3 over P2 in this case. So we are going to have this as P3 over P2. So having this here, representing A1 and A2, meaning to say we can rewrite our overall gain, the one that we have here, as in terms of power. So we can simply say our overall gain is equivalent to the product of A1 and A2, and A1 is equal to P2 over P1. That's our A1 in this case. A2, that's P3 over P2. So you're going to have P3 over P2, which is the power in this case. So thus we can represent this in terms of power. That's in terms of power. In terms of power in this case. All right. So in terms of power, let's say you are given your values there, you are given power there, you can simply use the power that you're given as it is. All right. So this is what we have as our gain, but we can have this represented now in decibels, that is using logarithm. Remember last time we talked about the use of logarithms. So we can apply the use of logarithms now, that is finding our answer in decibels in this case. All right, which can be referred to as the decibels method or the use of logarithms. So our answer in this case is going to be in decibels. So what is the idea that we are referring to here? When now you are using logarithms, the overall gain, which is our AP or our AT, depending with what you want to write, it is now going to be referred to as we are going to use the log now. So our overall gain is going to be 10, the logarithm of AP of in base of 10. So this is 10 log AP in base of 10. So this AP is the one that we got from our ratios. This one is taken from the ratios, all right, from the ratio method. So this one is the one that we took from the ratio method, meaning to say the product of A1 and A2, that's your AP. So that AP now is the one that you use to obtain the overall gain. So meaning to say, if you are to represent, if you don't want to use the product of this, you want to refer it one, you want to find the gain here, you find the gain here. So what are you going to do? You are going to say, or you're going to represent your overall gain in terms of logarithms as this. The overall gain is going to be 10 log. Here we are considering A1. Remember here there's gain 1 here. So it is going to be 10, the logarithm of gain 1 in base of 10. Plus we move on to the gain 2. So it's going to be 10, the logarithm of gain 2 in base of 10. So we are saying the gain here is the one that we are using. So we are adding these whenever you're dealing with the logarithm. So your answer now is going to be in decibels, all right? So this is what I'm saying. Instead of adding like this, you can simply find the product of this together, then you use it as your AP. It's one and the same thing. So in conclusion, before we check now, or before we look into the questions that I'm having for you guys, this is what I want you to conclude as. This power that we are talking about in all these gains that we have represented, you are supposed to go back to the formulas that we talked about in the previous class. So you're supposed to use the previous formulas. Which formulas are we talking about? Remember, we're talking about formulas of calculating power when you are given current, when you are given voltage, when you are given resistance. You must be able to connect these formulas in order for you to calculate the power, because you are going to need the power. If you are given the power, then it's an advantage. But if you are given current, voltage, resistance, your power from current and voltage is going to be voltage times current. From voltage and resistance, it's V squared over R. From resistance and current is going to be I squared R. So these are the formulas that we are going to expect also to be used as we are to calculate the power of any part that you be given. But this is what you need. The two parts are the ones, the use of logarithms and the product ratio method. These are the two methods that are very, very important in our syllabus. All right, so let us check how they are giving us, or how do they ask these questions. Like, as you can check here, we are given, calculate the overall gain of the network given below using, take note, they have given us what to use. 6.41, the product, which is the ratio method, the sum, which is the decibel method. All right, so I want us to consider what we talked about, these methods that we listed. Remember what I said about the product. The product method is the one that we are finding our overall gain by multiplying the gains that we are given here. So meaning to say our overall gain, you can write as A total, or you can write as AP. All right, so this is going to be the product of the gains that you're given, which is, as you are given here, it's given as AP1. You write the way that is given times AP2. If you are given as A1 and A2, you just multiply A1 times A2. But in this case, they wrote it as AP. Just write the way that you are given there. All right, but remembering that to find the gain, the first gain, we say the first gain is P2 over P1. We are now talking about the power in this case. So meaning to say we are going to consider P2 over P1. The second gain, output over input, which is P3 over P3 over P2. Remember, I talked about this from those formulas. So meaning to say you can calculate your gains here, which is fine, or you can substitute these ones into the formula since we've got the power. Gain 1, which is P2 over P1, times gain 2, which is P3 over P2. We talked about this on the formulas that I listed here for the product, that you can have this overall gain of product in terms of what? In terms of the power. When you are given the power, just use in terms of what? In terms of power. Or you can find these ones separate, which is fine. You can find this one aside, find this one aside, then multiply your answers at the end. You're going to obtain the same answer. So meaning to say our overall gain is going to be P2 over P1. P2, that's 20. P1, which is 5. So you're going to have 20 over 5 plus P3 over P2. So that's 100 over 20 in this case. So we're going to have 100 over 20. So I want you to understand these formulas properly. So that means you're going to have at the end here, if we reduce, that will be 4 plus 2 into 100, which is going to be, where am I getting the plus now? And I want you guys to understand me properly now. I'm using a plus. So there's a times here too. That is a 20, not a 2, this one. It's a 20 there. So 20 into 100, which is a 5. So meaning to say, if we are to multiply 4 by 5, that is going to be a 20. So that is our overall gain in terms of product, the product part, the product, which means if you were to calculate this, if you wanted to use that formula of multiplying the gains, you calculate your gain 1, which is P2 over P1, P2 over P1, 20 over 5, you're going to get a 4. That's your gain 1. You move on to gain 2, you do the same, P3 over P2, which is 100 over 20. So you're going to have 100 over 20 there, meaning to say our gain 2 is going to be a 5. But we are saying the overall gain is going to be the product of these two, which is A1 times A2. You have your A1, which is 4, and you have your A2, which is 5. So that is going to give us a 20, which is the same thing. All right, so that means you could have calculated separately like this, then you find your answer, or you can just combine the power direct as it is, like that part that we considered here. All right, let's check 6.42, which is the use of the sum method. And I said the sum method is the decibels method. That is the one, the use of logarithms. So whenever you're talking about this in decibels or the application of the sum, that is the use of what? The use of logarithms. All right, so we are talking about the use of logarithms. And under the use of logarithms, I said you can have these two. Either you're going to have these two. All right, that is going to be the overall gain, 10 log A1 is this, and so forth. All right, or you can use the overall gain from the sum of what? From the sum of from the product that we had, not the sum actually, but from the product that we had before. You can also use the same concept. So I'm going to explain these two. All right, so we said from the first one, if we are using the sum method, we are going to use as 6.42. All right, so the sum is now 10, the logarithm of the first gain. So our first gain in base of 10 plus 10 logarithm of the second gain in base 10. So this first gain, second gain are the ones that we are calculating from what? From P2 over P1. Remember, first gain, P2 over P1, P3 over. So you can substitute this into your formula, or you can just take these values because already you calculated them. But just for the sake of revision, this is going to be written as P2 over P1. Remember how you calculate the first gain. So it's going to be P2 over P1 in base of 10 plus the 10 logarithm. The second gain, remember, it was P3 over P2 like this in base of 10. Since our calculators can be used without the indication of a base 10, once you use a log without the base, it means it's in base of 10. You can even leave this base of 10. So I'm going to explain on a calculator what I'm trying to say. So this is going to give us 10 log. Remember P2 over P1. We calculated this before, guys. Just a repetition here. P2 over P1, it was 20 over 5, which gave us a 4, and so forth and so forth. So this one is going to be 20 over 5, which gave us a 4 plus 10 log. So we've got a base 10 there. P3 over P2, remember that was our 100 over 20. We calculated this one also. So what I'm trying to say on your calculator, let me show you the other part of the screen so that we can just use our calculator in the simplification so that you see that this is just one and the same thing. All right, we have our calculator here. If you want to, because it's base 10, you can remove this log, the log, this one, the base 10 that you're given. Here we know 20 divided by 5 is a 4. 100 divided by 20, this one is a 5. So we can simply use a 5. But if you want this base not to be indicated, you can present it this way. We can have it as 10 log, in this case, 4, because once you use a log like this, automatically it's in base of 10. So you can choose not to indicate the base, all right? Plus 10 log, so you're gonna have 10 log 5 in this case, which is 100 divided by 20 is a 5, which is going to be 13,01. If you want to use the one with the base, if you want to use the base 10, then we're gonna use 10, you use this log here with the base, this one. So it has a base of 10 there. So you're gonna punch the values 20 over 5, which is a 4. You want 20 over 5 like this, plus you use 10 log this one with the base. So it's gonna be, you start with the base, then you move aside, that's 100 over 20. So it's gonna be 100 over 20 like this. So still obtaining the same answer, 13.01. All right, so here we are going to obtain 13.01. Now our answer is measured in decibels. Now that's what I was saying to say, if you are given with the logarithm, our answer is now in decibels. All right, which could have, if we are to check now, because you are saying the sum, this is the proper method that you're supposed to use, but you are supposed to prove now if you are obtaining the same answer. Remember, we said this whole part that we see here, which is using the sum, can be shortened as AP is equivalent to 10, the logarithm. Okay, let me write as A total so that you don't confuse me if I say AP again. We are saying the overall gain, let's just say our A total in this case is going to be 10, the logarithm of AP in base of 10, whereby this AP is the one that you got from product. I said this one is from product. If you check here, what I was explaining, let me bring you back. Let me hear this part that I was explaining to say this one. If you are to use the overall gain as 10 log AP, which is from the ratio method, the ratio method is our product. Remember, if you talk about the ratio method, you're talking about what? The product. So this is a proof. We are not using this when they say sum method. You are just using this to prove your answer if it is correct. So this, our AP is the one that we calculated here, which is a 20. So we are going to have this as 10, the logarithm of 20 in base of 10. So I want to prove is this is going to give us the same answer as this one. So let us have our calculator. So what I'm saying here is going to be 10, the logarithm in base of 10 like this of what? Of 20. All right, so we are going to have 13.01, which is the same answer. So as you can see, we are obtaining the same answer, 13.01 in decibels. So these are the methods that you're supposed to know. The two methods, the sum, which is the decibel method, then the product, which is the ratio method. You're talking about ratios there. If we check again, there's a similar question that I want us to check here. There's a similar question to this one. This time, they wanted us, here we are given a network. It was question number 6, and we are given the network below shows part of a transmission line. So this is part of a transmission line that we are given. Then the question is calculate the input power P1 and the gain of amplifier into this one, this gain here, by using the given data. So here, it's not about calculating the overall gain, no. It's the knowledge that you know when you are given something that is in a multiple stage like this. So analyze the diagram. There is an input, the one that we were supposed to calculate, this one. We are given, what are we given here? And we are given this in what? We are given this in decibels. So meaning to say, we used the formula, we calculated the gain of this from P2 and P1, but it was the use of logarithms. The use of logarithms is the one that gives us in what? In decibels. The use of logarithms, this is the one that is giving us in decibels. So meaning to say, in order for us to calculate this gain, our gain is given as N1. So in order for us to calculate this gain 1, it was given as 10 log P2 over P1. So it's log P2 over P1 in base of 10. That is how we calculated it, so that it is in decibels like this. So meaning to say, we can substitute N1, we have it, so that we can calculate P1. N1 in decibels, which is our gain, we have this one, which is 10. So 10 is equal to 10, the logarithm of P2. Our P2 is 50 milliwatts. So I'm just going to write it as 50. If I write it as 50, I must know that my answer is going to be in milliwatts. All right, so that is the easiest way to calculate this. All right, everything over P1. All right, so let me divide this by P1. We do not have P1. This is the one that we are supposed to calculate. And this is in base of 10. All right. You solving this for P1, it's no longer about industrial electronics, what we are talking about. It's now your mathematical skills that you're supposed to apply. How do you solve logarithms? All right. So here we are multiplying by 10. So you can simply remove this by dividing by 10 both sides. This one, not this one, but this one that is multiplying. So you divide by 10, you divide by 10 both sides, so that here we're going to have a 1 is equal to the logarithm of 50. So this is the logarithm of 50 over P1 like this in base of 10. So remember, from your exponents and logarithms in your N2 maths, I say that the logarithm, okay, of A in base of B, if it is equal to C like this, it means we can write this in index form, which follows that this A is going to be equal to now B, the base to the exponent of C. So A is equal to B to the exponent, meaning to say this is our A, 50 over P1. So if we are to write this in exponents, it is going to be 50 over P1 like this is equal to the base to the exponent of the answer. Our base in this case here is 10 to the exponent of our answer here, which is 1. So this is going to be equal to 10 to the exponent of 1 in exponent, so that you can be able to solve. You can't solve direct with logarithms. You convert from logarithms to exponents. All right, so that is where we are now. So now we can solve because this is simply 10. 10 to the exponent of 1 gives us a 10. So this we can simply cross multiply because this is same as over 1. So we can cross multiply so that we can solve for P. By cross multiplying 10 times P1, if you multiply 10 and P1, that's going to be 10 P1, 50 times 1, which is 50. So to find P1, just divide by 10 both sides. So we have P1, which is going to be 5 in this case. So P1 is going to give us a 5. So remember what I said, these units that we are using, it's in milliwatts, milli, that is the major part. So meaning to say also our P1 is going to be 5 milliwatts. But if you converted, then you have to use the one that you got from your conversion. But here I used the 50 as it is. So meaning to say my answer also is going to carry the milliwatts. All right, so that was the first part of our question, to calculate the value of what? Of P1. So you take note, how are you given this? It's in decibels, so that's why we have to use the logarithms. If it was not in decibels, we're just going to use P2 over P1 direct as it is, but now it's in decibels. Also, they also clarified on the other part here when they are saying, okay, let me read this one. And also we are supposed to calculate the gain of the amplifier N2 by using the given information, by using the given what? The given data. So from this part, as we saw that the first gain was given in decibels. So also N2, we are supposed to calculate this in decibels. So meaning to say our N2 is going to be just the same as the previous formula. So it's going to be 10 log. Now we are considering the power that is affecting this block here. So this block is affected by P3 and P2. So it's P3 over P2. Remember your formulas, guys. All right. So it's P3 over P2 in base of 10. So that means we're going to have 10, the logarithm of, we've got, this is in milliwatts. This is also in milliwatts. So milliwatts divided by milliwatts will definitely cancel. So there's no need for us to write 500 times this. Just write the 500 because already we've got same units. So it's going to be 500 over 50 in this case. All right, so this is what you're going to have in the base of 10. So using your calculator, you can simplify this direct from your calculator, or if you want, you can do it stage by stage from your calculator. 500 divided by 50 is going to give us a 10. So that will be 10 log 10. In this case, if you actually know your mathematics, you can simply see that the answer here is going to be a 10. But anyways, let us just do this for the sake of all of us understanding on a calculator. If you check here on our calculator, we are going to have 10, a logarithm of in base of 10. So it's going to be 10 and here there's a 10. So this is going to give us a 10. So since we are using the logarithms, it means our answer there is going to be in what? Is going to be in decibels. So that means our N2, which is the one that they wanted us to calculate, is going to be 10 decibels in this case. So take note, it's not about calculating the overall gain always. Use the information the way that you are given properly. The information that you are working with for that particular question is the one that you are deal with what you are given. That is how best to answer these questions. Understand, analyze your diagram. Do not just look at the diagram, you rush to answer the question. Analyze it. How are they giving the information? Sometimes they might just interchange just to confuse you. So make sure you analyze your diagram before attempting any question that you be given. But that is exactly what you need in order for you to answer these typical questions. So let's revise this as we are preparing for exams because we might have a similar scenario like this one.